So today we're going to talk about two important topics in AP Cal, which are chain rule and implicit differentiation. These are two important concepts because involving many calculations such as the integral or differential of complicated equations. And some example of using chain rule is the differential of sine x squared, since that we only knew about the differential of sine x equals to cosine x, but we don't know, but we can use the rule to find the differential of sine x squared, just like that. So we need to use chain rule to solve it. And for implicit differentiation, an example of implicit differentiation would be like this, which involves x and y on both sides of the equation, and we need to find a differentiation for that. As previously mentioned, chain rule is a method for differentiation that can be used to differentiate composite functions. And the basic formula for chain rule is dy over dx will equals to dy over du times du over dx. This allows us to break composite function into two sets of differential, and then we use chain rule to combine it and therefore get the total differential of the equation. The first example we're going to do for chain rule is the differential of x plus 1 squared. Since that there is no equation for differentiating this kind of equation, we're going to use chain rule. And we previously mentioned that chain rule is using dy over dx equals to dy over du times du over dx. So we're going to make x plus 1 equals to u. So we basically differentiate that d over dx equals to of u squared. So dy by du, we can know from this equation is that it's 2u, and du by dx, we differentiate this equation and we got 1. So when we combine together, dy over dx equals to 2u times 1, which equals to 2u, and then we plug u equals to x plus 1 equals to equation, so it becomes 2 of x plus 1, which equals to 2x plus 2. And that will be the differential of x plus 1 squared. So the second example we're going to do is a complicated equation, which is the derivative of sine to the 5th of cosine to the 4th of 3x. This question involves a multiple chain rule, so we need to do chain rule a lot of times. So the equation of chain rule is dy over dx equals to dy over du times du over dx. So we're going to start from the outer one, which is sine to the 5th of cosine to the 4th of 3x, which is this part. So when we differentiate that, it will become 5 sine to the 4th of cosine to the 4th of 3x times the second part will be sine of cosine to the 4th of 3x, so the differentiating of that will become cosine of cosine to the 4th of 3x. And now we're going to do another chain rule, which is within the equation, which is the cosine to the 4th of 3x. So differentiating of that will become will become 4 cosine to the 3rd of 3x. And after that, we need to differentiate cosine 3x, which will become -3 sine of 3x. And now we're going to rearrange it, so it becomes -60 sine to the 4th of cosine to the 4th of 3x times cosine of cosine to the 4th of 3x, and times cosine to a third of 3x and times 3 sine of 3x. This is basically the derivative of sine to a fifth cosine to a fourth of 3x. So the final example we're going to do is the differentiate of integral from 1 to x squared of x cubed times sine root x of dx. So how we're gonna do this question is by using chain rule and the fundamental theorem of calculus. So the chain rule is dy by dx equals to dy over du times du over dx. And the fundamental theorem of calculus is when f of x equals to f dash of x, the integral from a to x of f of x and then differentiate will still equals to f of x. So using these two rules, we can solve for this question. So since that the fundamental theorem calculus requires that this part must be x and our question this part is x squared, we're gonna use a variable to change it. We're gonna change it to u, so it become d over dx equals to from 1 to u from 1 to u of x cubed sine root x of dx. So now we're going to separate into two parts, which is dy over dx equals to dy over du times du over dx. For this part, we're gonna this part is basically equals to this part, which according to the fundamental theorem of calculus is still the same thing. So it become u cubed times sine root u. And then since we know that u equals to x squared, du equals to 2x times dx. So that after we rearrange it, du over dx will equal to 2x. So basically du over dx equals to 2x. And then after we substitute x squared for u in the equation, we can get x to the 6 times sine x times 2x, which after simplifying equals to 2x to the 7th times sine x.
So implicit differentiation is a method of differentiation that involves differentiating both sides of functions. There are three steps for implicit differentiation, which are differentiate both sides with respect to x, and then put dy over dx to one side and other terms to another side. The last step is to factor dy over dx and solve for dy dx. Therefore, you will have dy over dx on one side and the rest of the equation on the other side. And in that way, you can find the differentiation for the equation that involves both x and y.
So now we're going to do the implicit differentiation for the equation of circle x squared plus y squared equals to 1. And so we're going to differentiate both sides of the equation, which will become 2x plus 2y times dy over dx equals to 0. And then the next step, we're going to put dy over dx on one side and the others on the other side. So it becomes dy over dx times 2y equals to negative 2x. And then after we arrange it, dy over dx will become negative 2x over 2y, which is equals to negative x over y. And that will become the implicit differentiation for the equation of a circle of x squared plus y squared equals to 1. So we're going to use the implicit differentiation in a harder equation, which is the differential of y equals to x to the x. Since there's no equation for differentiating that, we're going to use implicit differentiation. So we're going to take ln on both sides, will become ln y equals to x times ln x. And then now we're going to differentiate both sides. So the left side will become 1 over y times dy over dx equals to, on the right side, since it's a product of two functions, we're going to use product rule to solve it. So we're going to differentiate the first one, so it becomes ln x times 1 plus, and then we're now going to differentiate the second one, which is x plus 1 over x. And then if we rearrange it, it will become 1 over y times dy over dx equals to ln x plus 1. And now we're going to move dy dx to one side, so dy over dx equals to y times ln x plus 1. And since y equals to x to the x, we're gonna plug into the equation, so the differential for that is dy over dx equals to x to x times ln x plus 1. So the last example we're going to use is the equation of 5x squared minus 2xy minus 7y squared equals to 5. And since that there's no equation for differentiating this, we're going to use implicit differentiation to differentiate this. So we're going to differentiate both sides first. The left side will become 10x minus 2x. And since the middle part is a combination of function, we're going to use product rule to differentiate. So it becomes 2x times dy over dx plus 2y. And then minus 14y times dy by dx and equals to 0, since it is a constant, so the differentiate of that equals to 0. And now we're going to rearrange that, so it becomes 10x minus 2x times dy by dx minus 2y minus 14y times dy by dx equals to 0. And we're going to put dy by dx all on one side, so dy by dx times 2x plus dy by dx times 14y equals 10x minus 2y. And we're going to factor it out, so dy by dx of 2x plus 14y equals to 10x minus 2y. And we're going to divide this thing to the right side, so dy over dx equals to 10x minus 2y over 2x plus 14y. And after simplify, we can get 5x minus y over x plus 7y. So the common mistakes for chain rule and implicit differentiation is sometimes that people will forget to times the second part of the differentiation into the answer. For example, when doing question like sine to the fourth of 3x, people tend to write 4 sine to a third of 3x and just leave it like this, which is wrong because they forgot to time the du over dx part. So the correct way it should be right is 4 sine to a third of 3x times cosine of 3x and times 3, which equals to 12 sine to the third of 3x times cosine of 3x. And that's the common mistake of chain rule, which is forgot another part of the differentiation. And for the common mistakes for implicit differentiation is that people tend to forget to times dy dx at the right places. For example, when doing question like x squared plus 2xy minus 4y squared equals to 5, people tend to write 2x plus 2x plus 2y minus 8y equals to 0 and forgot dy over dx. The correct way should be 2x plus 2x times dy over dx plus 2y minus 8y times dy over dx equals to 0. So basically, when you're doing differentiation of y over x, you need to times the dy over dx after the term, so it will be correct.